The Schrodinger equation just does not let that happen.
And to put it mildly, we've got quite a lot of evidence for that structure of physics, and for a whole bunch of reasons, actually trying to change the physics to make that sudden collapse of the wave function physical, and not just, as Joab was putting it, not just a sort of fuzzy talk, is a really, really difficult technical problem. But you could say that we have to do that because, like Brian was saying, it doesn't seem we ever see a particle here and here at the same time. And I think Brian's joke is about right as to what our intuition is about what it would be like to see a particle here and here at the same time. It would be like being really drunk, like seeing double. But here's the thing. If you want to work out what some physical process would be like, and my looking at a particle is just one more physical process, turns out intuition is not a very good way to predict what happens. So how do we ask, what would it really be like to see a particle that's here and here at the same time? Well, what does the physics say? I'm just one more measurement device. And the physics says something like this. If I saw the particle here, I'd go into a state that you might call a seeing the particle here state. If I look at the particle there, then I go into what you call a seeing the particle there state. If it's in both states at the same time, then I go into both states at the same time. So being a little loose for the minute, then I'm now in the state seeing the particle here and seeing the particle there. And if I tell Brian where the particle is, because I'm sure he's fascinated, Brian's now in the David says it's here and David says it's there